So in the fourth video, we're going to do the rules of how you balance oxidation reduction reactions. I'll write the rules on the top, and then we'll do an example problem on in the middle here. I have to write it pretty small to get it to fit across. Oops. Alright, gotta make that a little better. Okay, so the first thing you do is use the correct pen color. Okay, first rule is assign oxidation numbers. So to do this, I'm going to put my parentheses in here to make things a little bit easier. Okay, so dichromate's got a charge of -2, and potassium's got a charge of +1. Whoops. Charge of -2, charge, goofed it up again. Charge of 2-, charge of 1+. Okay, hydroxide has a charge of 1-, 1+. Okay, so those are our charges, and monatomic ions are the same oxidation number as their charge. Okay, elements have an oxidation of 0, and sulfur has got an oxidation of 0 because sulfur is an 8-some. If you don't remember from chemistry of last year, the 7 diatomics are all the halogens, and nitrogen and oxygen and hydrogen. And then the other is phosphorus is a P4 and sulfur is an S8. So those are the polyatomics. So sulfur comes as an 8-some. Okay? And then oxygen is always a -2. Hydrogen is always +1. All right. -2, -2, +1. I lost my parentheses somehow there. Okay. Remember that the oxidation numbers inside must have to add up to your charge. So because oxygen's a -2, 7 times 2 is -14, that means my chromium must be a +6. Okay, so +6, because 2 times 6 is 12, 7 times -2 is -14, 12 minus 14 gives me my 2- charge. Okay, now I really no longer need that charge over there, so I'm going to erase it so I don't have to get confused by it. Same thing over here. Oxygen is -2, hydrogen's +1, so it adds up to my charge. I'm going to erase my charge because I no longer need it. So what about the rest of these guys? If 3 times 2 is -6, my chromium would have to be a +3. And over here, 2 times negative 2 is negative 4, so my sulfur would have to be a plus 4. Okay? So after you assign the oxidation numbers, identify who is being reduced and who is being oxidized. So identify the oxidation and the reduction. Okay? There always must be at least one oxidation and one reduction. Okay? So the thing whose oxidation number gets smaller is being reduced. Okay? So I'm just going to write some oxidation numbers here. It's 5 plus 4. I wrote them way too big. I'm just going to do it down here. Plus 5, plus 4, plus 3, plus... Oh, God darn it, I'm going to run out of space again. Okay, take 3. Let's just start here. Plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. So if your oxidation number is getting smaller, you're being reduced. If your oxidation number is getting bigger, you're being oxidized. Okay? So even to this day, I always have to kind of draw this out to remind myself which direction I'm going, because going from negative 2 to negative 1, that's actually being oxidized. Okay? And going from negative 1 to negative 2 is actually being reduced. So if you're getting smaller, you're being reduced. If you're getting bigger, you're being oxidized. Okay? So looking at our oxidation numbers, who is being reduced? Well, I can tell you right now that this chromium is going from plus 6 to plus 3. So that means the chromium is being reduced. Okay? So I begin by writing, and you can identify the oxidation first if you want. It really doesn't matter. But I always like to find the reduction first. So then I write down the species on the reactant side that is being reduced. Okay? Then I look for my oxidation. You can have more than one reduction, you can have more than one oxidation, but you got to have at least one of each. Otherwise you can't have an oxidation-reduction reaction. Okay? So let's take a look at whose charge is increasing, whose oxidation number is increasing. So sulfur over here is 0, over here it's plus 4. So the sulfur has oxidized. So then I write my S8 over here. Okay? Third rule is to balance all elements except hydrogen and oxygen. Okay? And the little trick here is when we balance it, we can only balance with the compounds or elements found in the reaction. So you'll see what I mean here with this one. So I've got 2 potassiums, so I'm going to need 2 potassiums on this side. So I balance it by putting 2 potassium hydroxides. Okay? So that's the only place I can get potassium is from potassium hydroxide. I got 2 chromiums, so that means I'm going to need 2 chromiums on the other side, and I get my 2 chromiums from the chromium trioxide, sorry. Okay? So everything except the oxygens and hydrogens are balanced. Okay? Now I have to balance in step 3, or step 4, balance oxygen by adding water. Okay, so I have 7 oxygens on this side, and I got 5 oxygens on that side. So that means I'm going to have to add 2 waters to this side to get my oxygens to balance. And now I have 7 oxygens on each side. Then I'm going to balance the hydrogens by adding H+. Okay? So I've got 2 hydrogens there, 4 hydrogens there, so I have 6 hydrogens on this side. So that means I'm going to have to add 6 H pluses to the other side. Okay, so now I've got step 6, balance charge by adding electrons. Okay, so if I have 6 positive charges here, okay, now in these early reactions, the number of electrons and hydrogens will probably be the same, but that's coincidence. The number of electrons and hydrogens do not have to be the same. But in order to balance my charge out, because there's no charge on this side, there is 0 charge on that side. So that means I must have 0 charge on this side, so I'm going to add 6 electrons to this side. Okay? So the 6 negative charges cancels with the 6 H pluses. Okay? Alright, so now we're going to do the exact same thing with my oxidation. Balance everything except oxygen and hydrogen. So to balance my sulfurs, I'm going to add 8 SO2s. Okay? And then I need to balance my oxygens by adding water. So I've got 16 oxygens on the product side, so I'm going to need 16 oxygens on this side. Okay? Now I have to balance my hydrogens. 16 times 2 is 32, so I'm going to need 32 H pluses on that side. Then I have to balance my charges. I'm going to need 32 electrons to balance out with those 32 H pluses. Okay? So, again, the number of hydrogens and electrons being equal is just a coincidence. It doesn't have to be that way. If there were charges on other species, let's say there was like a 2- on this thing or something like that, the number of hydrogens and electrons would not equal. But we'll save that for a later chapter. Okay? So the 7th rule is to balance electrons. With the lowest common multiple. Okay? So what is the lowest common multiple between 6 and 32? If I'm not mistaken, it's 96 is the lowest common multiple. So that means we're going to have to multiply, oops, take that away. We're going to have to multiply that didn't look good. Multiply this reaction by 16, and we're going to multiply this reaction by 3, because 16 times 6 is 96, and 3 times 32 is 96. So I'm going to try to get some more space. Something's wrong here, sorry. Okay. So okay. I can't seem to scroll down. Okay, so I'm just going to try it here because I can't scroll down. So 16 times 6, that's going to turn this to 96. This is going to turn to 96. This is going to be 16 out front. This is going to be 32. This is going to be 16. And this is going to be 32. Okay? Down here, we're going to multiply everything down here by 3, so this becomes 96, this becomes 3, this becomes 24, this becomes 96, and that was my H pluses that somehow got disappeared. And this is going to become 96 electrons. Okay, the number of electrons must cancel each other. Okay, and the number of electrons must be on opposite sides. So this 96 over here and this 96 over here cancel. Okay, and so now all we have to do is add these two reactions together. I'm going to see if this works. Okay, so let's add these reactions together. So we get, what else cancels here? The 96 H pluses cancel. Okay, I've got 96 waters on one side. The other side I've got 32, so 32 of those will cancel, and that'll leave me with 64 waters. So I'm going to have, and I think those are the only things that cancel, so that means I'm going to have 64 waters. Actually, I'm going to follow the same pattern on the homework. I'm going to have 16 potassium dichromates. I'm going to have 64 waters. I'm going to have 3 sulfurs. It's going to yield 24 sulfur dioxides and 32 potassium hydroxides. And 16 dichromates, or chromium trioxides. All right, so let's check to see if this is correct, okay? Now, if you had unlimited time, you could go and check all of the elements to see if this is balanced right. If you didn't have unlimited time, just check the oxygens. If the oxygens are right, then everything else must be right, okay? So let's see here. I've got 32 potassiums on that side. I've got 32 potassiums on that side. I've got 32 chromiums on that side. I've got 32 chromiums on that side. I got 24 sulfurs. I've got 24 sulfurs. Let's check the oxygens because that's going to be the tough one. So 16 times 7. So 112 oxygens plus another 64. That's 176 oxygens on the reactant side. On the product side, 24 times 2 is 48 oxygens plus 32 plus 16 times 3. And 48 plus 32 plus 48 is 128. Let's see. 16 times 7 is 112 plus 64. I think I made a mistake up here. I'll find it. It'll just take me a second here. It's probably I made a mistake with the waters. So let's see here. Let's take a look at the reduction. 24, 24, 48. Yeah, I don't have 96 here. I goofed that up. So I've got 20, I should have 48 oxygens here, which means I'm going to have 48 times 2 is 96 hydrogens, so that's right. So that's where I goofed up. So that means I'm going to have 12 waters. 32 will cancel and leave me with 12. So this is not 64, it is 12. Just a slight difference, but all is good. So 12 times 2, so we got 16 times 7 is 112 oxygens, and then another 12 gives me 124, 48, 32, 16 times 3, 128, 16 times 7 is 112. Okay, I still have a mistake up there. I gotta go back and check. Okay, let's see, 16 times 7. $32 goes with the potassium hydroxide. 16 goes with that. And sulfur dioxide. Oh, because I can't do subtraction. Jeez Louise. 48 minus 32 is not 12. For goodness sakes. 16. Goodness gracious. Yep, I'm really instilling confidence in you guys, aren't I? Third video. Alright, so now it's all set. And as you can tell, these things certainly take a long time. But you would never get this by guess and check. These problems take a long time, but as you get better at them and better at them, you can be as good as me at them. Alright, so that was a joke, by the way, in case you didn't know. Have a good evening, and I will talk to you later.